session now. Yeah, so Paolo has more than 20 years of experience in IT. He recently joined Oracle as a cloud platform architect, and he is tremendously committed to the Swiss Oracle user group. Yeah, that's correct. And he's a driving force to all of us and loves to share new technology and from Oracle. So today he will speak about multi-tenant, and the question is, to multi-tenant or not to multi-tenant? So Paolo, please enlighten us.
Thank you, Flavio. So let me share the slides and let's start. Whoops, share screen. Okay. Everybody should see my screen now. I will stop my video just to spare some bandwidth. And let's start. So this talk will be about William Shakespeare. Yes, I will also talk a little bit about Oracle and about Oracle technology, but the main important thing will be William Shakespeare in this talk. So William Shakespeare, I think everyone knows. I will demonstrate in this session that William Shakespeare, if he had lived today, he would have had the chance to be a very, very good, one of the best DBAs all over the world. But unfortunately, at his time, there was no multi-tenant, there was no Oracle technology, and so he is only known as one of the biggest poets that ever lived. And yeah, so let's see if you will agree with me at the end of the session. There will be a lot of actors that will help us and that will support. These are actors that played in their career the pieces of William Shakespeare. And as I've seen that people are very shy asking questions, I would like to use the question and answer part just for a little game. There will be several actors, and each time you will see an actor, you will see here this yellow box, actor number 1. And feel free to write the name of the actor with the number of the actor in the question and answer chat, and we will have a look at the end of the session. So at the end of the session, who wants to know who is who, just remain here. Everyone who gets the first the name gets 1 point, and the winner will get a prize. You can start with actor number 1, and you see. Okay, so this is our safe harbor statement. And about me, okay, I was born quite a lot of time ago in Genoa. I have a master's degree in informatics, and I worked many years as freelancer, Oracle DBA and developer. Then I settled to Switzerland as an Oracle University trainer, and 2010 I joined Swiss Mobilia, where I've been the Oracle technical lead for some time. Then I had the responsibility of all of the team, and the last years I worked as a DBA architect and focus also on open source databases. 2019 October, I joined back to Oracle as a cloud platform architect with focus on data management. And as Flavio said, I'm a proud member of the Swiss Oracle user group, helping in organizing events like this one, the first virtual event. So we will start. Just a little recap about the multi-tenant architecture. And the multi-tenant architecture is divided in 2 parts. We have the pluggable databases, the PDB, the self-contained PDB, and these are the database from the point of view on the application, because application run unchanged in the PDB and contain all of the objects that are necessary for the application to work, from the user schemas to the object schemas, tables, indexes, the services to connect on, and so on. The second part here is the CDB, so the container database. This is more the database from the point of view of the DBA, because most of the administration tasks will happen on the container level. So you will perform backup, you will perform upgrades, you will manage high availability, everything happens on the container database. And background processes, memory allocation, different OS resources, everything happens on the container database. When I joined Oracle again, I was involved immediately in different talks with customers about the container database architecture. Why? Because at September 2019, Oracle announced that we will support the non-container architecture. So single instances will not be supported anymore. Starting with license C, you will just have the possibility of create three pluggable database in a database. Was this a big surprise? Not really, because the deprecation means that Oracle announces that they will desupport a feature or an architecture or so on, was announced 2013 with 12.102. So then Oracle said, customer, have a look, we will desupport it. And starting from 2013, if we look at 19C, that is a long-term release, people have more than 10 years to change the architecture and other 3 years with extended support. But this creates some question to customer. Now they know they will have, and they are starting new soliloquies. What are soliloquies? Soliloquies are an act of speaking one's thoughts aloud when by oneself or regardless of any hearer. So I can imagine customers late at night not be able to sleep and thinking about what should I do? Should I only change the architecture, or should I have a look also at the multi-tenant option, because there is an option behind the architecture. So maybe we can replace the skull of the father of Hamlet with our multi-tenant architecture and see that the new soliloquy will be to buy or not to buy the multi-tenant option, whether it's nobler the mind to suffer the slings and arrows of cost saving, or takes the arms against a sea of troubles and by innovating end them. So this is the first big question that we have here. Should we do it? Should we take the multi-tenant option? What does it bring me to us? Or should I just save cost and go on with the with the architecture with one CDB and maximum 3 PDBs? Here you have actor number 2. If you want to vote, you can. And the next character of Shakespeare tell us what he would have done. He would have done and waits thy word before you give them breath. So think about it and try to have a balance between pros and contras. And this is exactly what we will do. So we have a balance here, and we will see that the first main argument I think customers will have is just a question of costs, because the multi-tenant option needs an investment. It needs capital expenses. So capital expenses is what you pay when you buy the license, and operational expenses that are maybe recurrent expenses like support and so on. And we will see that something here is missing, because you cannot think only in terms of CapEx and OpEx. There is an actor who is missing here on the scene, but we will see it later. On the other side, if we have a look at the slides from our product management says that multi-tenant is the perfect option to minimize CapEx and minimize OpEx and maximize the agility. So is there a mismatch between what customer are thinking and what product manager are thinking? Let's have a look at it. What would Shakespeare say? And once again, in Antony and Cleopatra, he just knew. He said, had our great palace the capacity to camp this host, we all would soup together. So he was complaining that the palace was too small for all the new Romans that were coming. And I think it's the first example of capacity planning. Capacity planning here. And let's try to have a look at what it means and what are the advantages of using the multi-tenant option for optimizing capacity and for doing some consolidation. Just have a look. Maybe we have here a 2-socket server with 96 GB of RAM. Here in this example, we will try to place different VMs on this server. And the VMs normally have a footprint for OS, a footprint for the VM itself. So it's memory that you will have to allocate to your VM. And if you start allocating different VMs, here we have 6 GB. You can also have 4 GB, but you won't be happy. You will see that you will arrive at one point when the memory of the server will be full, but you would have CPU power. So you will have a waste of CPU power, and CPU means licenses. On the other side, if you put on the same server the PDBs in just a container, then you will see, because the footprint in memory on CPU from a PDB is very small, you will see that you may have much more databases or much more PDBs on your server. Too many PDBs for a CDB maybe. We will see some real world numbers, and we will see that there are customers who are putting much more PDBs on a CDB than explained in this picture here. Another example are peaks, CPU peaks. Here in this example, we have 3 databases. This is the normal behavior of the databases because they are in different time zones. But we can also have some databases that maybe have more jobs during the night, and other databases who have more jobs during the day. So here, if you put those 3 databases, each one in a different VM, you will have different workloads. You will have to size each VM for the highest workload they can achieve. But if you consolidate them and put them together, then you will see that the sum of the 3 workloads will be less than the peaks of every workload. Is it just something that happens also in real life? Indeed. This is a very old slide that I showed in 2014 at the German Oracle user group. This was about the migration we had at that time at Swiss Mobiliar from VMs, in this case LPARs on a P series, to bare metal machines. And we were looking, do the different database fit together? And here we've taken just a metric, the session logical reads, that is for CPU. It's a good indicator for CPU power. And we saw that these 3 databases, a risk management database, a data warehouse, and a GIS database, they were just working. We tried to put the load together per day, and we saw that we had here quite a big peak. So we were asking ourselves, is it really a peak? Can we put these 3 together? How do we have to size the machine? But looking more at the day here, zooming this part and looking at the per hour metric of the session logical read, we noticed that the blue database was running his monthly job during the night, and the data warehouse people were working during the day. So they really fit together. And so it's something that people can do and should do. And if you have this information, you can just try and begin to size your CDB with the different PDBs. But you will have only a photo of the moment, a snapshot. And also, Shakespeare told us, if we can look into the seeds of time and say which grain will grow and which will not. So what happens if one of those databases starts growing? Would it take the power from all of the other databases on the CDB, and which possibilities do we have to avoid those problems? So let's have a look what happens. Here we have the normal behavior of a CDB without any PDBs, of the CDB with 3 PDBs, and without setting any parameter. So without instance caging, we will introduce it in a couple of minutes. You may see little CPU contention at the beginning, but if the red one, the red database starts having more and more demand for capacity, you will see that after some time, the system run queue will increase, this gray part. The system run queue are processes that demand for CPU and then they have to be queued by the OS, by the operating system. And this is a very good indicator for showing that your system is under pressure. Therefore, maybe also here we can see that this red one, it's consuming more CPU like other because it's demanding more and more and more, and the other have less CPU to use. Okay. And this is something that happens also in real life. Once again, from this old presentation in Germany, this was something that happened also at our site, where an 8 GB database started looping during the Christmas holidays and on a VM, on an isolated VM, and it started to produce more session logical reads, means more consumption of CPU than all the other all the sum of the data warehouse, the sum of the risk management database, and the sum of the GIS database. So it's a real problem and you have to do something for it. You have two different possibilities. Using Resource Manager, you can decide to partition with the parameter CPU count your system. So you have now 3 PDBs and you have 96 CPUs on the server. And you decide to assign a maximum of 32 CPUs for each server, for each PDB. So when all databases are busy, the server is totally utilized. That's good. But when the two blue ones have less pressure and demand for less CPUs, maybe the red one would like to have more CPU, but he can't because it's capped. So in this example here, you are sure that you will have no run queue, but on the other side, maybe you cannot use the exceeding CPU for other PDBs. An alternative could be to do instance caging with oversubscription. Here you are defining 120 plus 24, 144 CPU counts. So you have 96 physically, but you have 144. And if you know your workload, then you can just say, okay, maybe I hope not to reach the maximum amount of CPU on all the databases at the same time. So if the 3 databases do not consume all of the 48 shares, you probably will use better the resources on your system. On the other side, there is still the possibility that all the database demand for performance, and you will go into using the system run queue. It depends on how your database behave. The main question is now, but what happens if I do oversubscription and there is one database who tries to get all of the power? Or better to say, can I distribute the CPU load to the PDBs in a different way? I have some big PDBs, I have some medium PDBs, and some small PDBs. To the small PDBs, I would like to give less CPU rather than to the big CDBs. And there's a new parameter starting with 19.4, that is CPU min count. You can set it at the PDB level, and we will see what happens now. So CPU min count has to be less than the CPU count on the CDB. So that here, for example, you have the 2 blue ones who are demanding more and more power. And the red one has a CPU min count of 20. This means that the red one will get his 20 CPUs because they are guaranteed. So these are possibilities for you to size your system. So due to the fact that you can consolidate your environment, maybe the balance we saw at the beginning, here are still CapEx and OpEx, could be less because you are sparing some resources. There's more to say, and we'll have a look at it after some time. Another question is about how much does it cost in time to implement all of these architectural changes? So you have to deal with the new architecture. And this is exactly the same thing that Shakespeare told us. He said, oh, for DBAs, time and the hour run through the raucous day. That means DBAs normally have not so much time because they are fixed with tasks and they cannot try out new things or try to deal with the new architecture. They do not know exactly what comes up to you. So I just asked somebody who just did it. And I asked Gerald Bella. Who is that guy, Gerald Bella? If you search for Gerald Bella Oracle Mobiliar, you won't find any result. Why? Because Gerald Bella is a silent hero. Gerald Bella is one of those people who you will never see at a conference talking about something, who is not on social media, who is not twittering out, but he does a huge work. And he's the DBA that does the automation at Swiss Mobiliar. Swiss Mobiliar was reference customer for multi-tenancy, and he was the one who, for example, implemented all the scripts for cloning and so on, and also from the upgrade. And once Mike Dietrich, Master Product Manager for upgrade, came to our site, to Mobiliar, to have a workshop, and he asked, how are you doing the upgrade? And Gerald showed his script that was performing quite a lot of a requisite task like collecting system statistics and doing a backup before starting, and then implementing all of the steps of the of the upgrade itself, and also the post upgrade steps. Everything automatically with the possibility to restart the script after an error without having to restart all of the process. And Mike was really fascinated from the script here. So he took a screenshot from it, he showed it at OpenWorld, and he asked Mobiliar to provide him the script because he wanted to show him the script as his developer. And this is the idea how the auto upgrade tool, the first time he was discussing with his developer about the auto upgrade tool. So his script was shown at the Oracle OpenWorld. And so I asked him, because he knows he did the work, and he gave me an answer, how much time it costed for him to change the automation script for dealing with a new architecture. He said, okay, 5 days for Oracle restart, 10 days for create PDB CDB, 5 days for drop CDB, and so on. And he said, it took me about 60 days to do all of the changes in the scripts, in the administration scripts. What he also told is that then he had about 6 months with different little changes just to some troubleshooting or just changing some lines, but 60 days full work and 6 months then with 1 hour maybe a day. And the interesting thing is that most of these tasks here do not deal with the multi-tenant option, but deal with the multi-tenant architecture. And due to the change, companies will have to do it anyway. And more, he told me, many scripts became simpler because some commands became one-liner because they had the possibility to use features. So one-liner features rather than big complicated scripts. So at the end, maybe that after you implement it, you will have quite a lot of advantages in the manageability. And another thing, you will be prepared for the future. Because, like once again, Shakespeare tells us, Lord, we know what we are, but not what we may be. In Hamlet, this is Ophelia that's telling it. And that's true. Just have another look at the Mobiliar use case. Many of this information are from his blog. Their blog, they have a fantastic blog where they write about their experience with the multi-tenancy. And it's very interesting. I will come out to the blog in a couple of slides. The new challenge for Mobiliar this time were microservices. And once again, the team said, okay, it's not in the stars to hold our destiny, but in ourselves. So the DBA team, they knew there will be a new challenge we have to do something, because with the infrastructure we have today, we will not be able to host, I think, maybe 500 microservices in one database. Or they would have to create 500 single instances with quite a lot of consumption at the CPU level for background processes, for backups, for statistics. The old architecture would not fit. So they decided to go proactively and do some changes. This is a slide, an original slide from Alafura. He's now the product owner for the database at Swiss Mobiliar. And this was presented 2016, when Mobiliar decided to buy the multi-tenant option. They said, we plan to reduce the physical databases between 20 and 30%. So this was a plan. They did not know if they really would achieve it, but they said, this is our goal, at least a reduction, so that Mobiliar would not have to buy additional licensing, so no additional server costs, and on the other side, no new licenses for new servers. Here, in this example, Mobiliar did not think in terms of CapEx and OpEx. They thought, how can we handle the future? Flexibility, naming limitation, and so on. There were quite a lot of other arguments. The new architecture, they knew that the new architecture would change, and ready to face the age of development. And the sponsor here was a future IT project. So they got the money from a project that had not his goal to reduce costs, but to be ready. And normally, when you take a decision and you buy something, you do not look back. We will look back and have just an idea what would have happened if Mobiliar would not have taken this decision. So 2016, they bought the multi-tenant option. In 2014, they tried just a schema consolidation, a first consolidation that would not have worked with microservices. So they reduced from 550 to 380 databases, but they knew that due to the microservice, the number of databases would rise again. So with a multi-tenant option, they achieved in 2018, these are numbers that are taken again from the Mobiliar blog, 130 CDBs with 1,350 PDBs. And in 2020, they have more growth because they reached 2,000 PDBs only with 60 CDBs. So the consolidation worked. And Mobiliar, I think they saved a lot of cost. Imagine to run 2,000 PDBs on the old infrastructure. That would not have been possible. So the actor who is missing is the return of investment. So this is the third parameter you have to look at, and you have to think, okay, if I'm thinking about buying the multi-tenant option, I have also to think in terms of the return of investment. What will be our future? What do I expect? And where can this option help me? So here, the takeaways. Without the multi-tenant option, you can have a maximum of 3 PDBs per CDBs. Resource consumption is just limited. If we look at the Swiss Mobiliar, they are driving 150 microservice PDBs per CDB. So the slide at the beginning with all the PDBs in a CDB, Mobiliar reached the 150. Don't focus only on the database budget. Look at the big picture, because you will be sparing also budget from the server side, from the network side, and so on. And don't think only about CapEx and OpEx, but consider return of investment. Here, once again, these are real world numbers taking from the Oracle blog, the blog from the Swiss Mobiliars. 735 PDBs in 5 CDBs. That's great. So that's what says then Shakespeare. He says, let not advantage slip, find the time. So if you have the possibility to have an advantage and to spare time, just do it. And we will see how we can minimize operation expenses. If we look at this title, it is very interesting because it shows which are the tasks that will be performed on a CDB and which on a PDB. So patching, backup and recovery, class administration, high availability, database provisioning will be performed at the CDB level. And at the PDB level, you will have user administration, performance tuning, and so on. So about 60% of the normal task of a DBA happens on a CDB. And if you reduce the number of CDBs, maybe you will reduce your operation expenses. Just make an example. How much time does it take for you to upgrade 30 databases, single instances? Well, the first thing is just an administration task. You have to schedule a time window for 30 DBs. That's not so easy. But the other way around, maybe you have a release and you have 1 day for doing all the application changes and also the upgrades. So let's assume that we have a release. Then assume 2 hours per database, including pre and post upgrade tasks. You have to take a backup. You have to do a post backup. You have to do some cleanup. There are quite a lot of things that you have to do. And 30 DBs, 2 hours are 60 hours. Then you will need at least 4 DBAs for doing it in a day, so that you go back to 15 hours, and your DBAs will have to do 2 upgrades in parallel. Maybe they won't be so happy to have an upgrade in parallel, but I think there's no other way. So that at the end, you will result in 7.5 hour work for 4 DBAs. But do you have 7.5 hours doing a release? There are also some application changes. People would like to know what happens on the database during their release, or they will have to provide you some script to run on the database to do some schema changes. So in the release day, you won't have 7.5 hours only for you. There are quite a lot of people working. Therefore, you will start during the night, maybe the upgrades. But that means that at the next day, you will need other DBAs to watch for the release. And you will have all of your people maybe working during weekends. That's a great thing. Let's have a look what happens with CDB and PDBs. I have taken here a VM and I run the upgrade in parallel, because with the CDB architecture and the CDB option, if you have many PDBs on a machine, you can just start a script and run it in parallel. On this machine, we have 16 OCPUs and we have 240 GB of memory. I decided to use a parallel degree of 16 because I have 16 OCPUs. So the first step is the upgrade of the CDB root that took 30 minutes. And this is a single task. You cannot parallelize this. And then 2 sessions of upgrading PDBs. And every PDB took about 20, here you see the numbers, 29, 30 minutes, some 34 maybe, some more because they were a little bit more complex, with a total upgrade time of 104 minutes. So it's different, rather than having 4 DBAs working for 7.5 hours, to have 1 DBA, because the manpower this task can be done by 1 DBA only for 1.5 hours. So you really can do it maybe 7 in the morning, and at 9 o'clock when the release starts, it's all okay. So this is one way. If you cannot upgrade every PDB, all of the CDBs at the same time, you can just also do an unplug, plug, and upgrade. You will create an XML file. You will take the XML file and import it on a second CDB with a different level. And then you just have to start the upgrade. And it's done. Time, about 30 minutes. And again, the use case could be the upgrade of a single microservice. So we've seen the upgrade. What about database provisioning? Database provisioning, Shakespeare knew. He said, better 3 hours too soon than a minute too late. People are demanding for having databases provisioned fast, because times are getting shorter and shorter, also for development and also for testing. And there is a very interesting feature. This is the create pluggable database, the fast cloning of a PDB, create pluggable database PDB2 from PDB1, for example. And this is very fast because it does a file copy and creates a new PDB locally on the CDB, or you can do it remotely. Just have a look at some numbers. Again, these numbers are taken from Swiss Mobiliar, but I did some tests on a VM with STDs attached, and I reached exactly the same numbers. So here you can see that at Swiss Mobiliar, the clone of a terabyte went from 2 hours to 8 minutes and 20 seconds. So this is a big, and over the LAN to 17 minutes. So they became about 7 times faster to deliver a test or refresh of a test environment. The important thing is that, for example, the data warehouse that was about 10 terabytes went from their creation of a test environment from 10 hours to less than 3 hours. And I wrote here, excluding faults. That means, for example, if you start at 5 o'clock, the refresh of a test environment that takes 20 hours, the next morning you will come in the office and maybe something got wrong. So that these hours that you have taken, the 16 hours, you will have to restart it again and have other 20 hours. So people will be waiting for 16 hours longer than expected. And if you have a second problem, then people will start complaining very loud. On the other side, if you have only 3 hours, then you can start it at 5 o'clock, have a look at from home at 8 o'clock in the evening. If something went wrong, you just restart it. The next morning, you have the test environment. People were very happy. But once again, here Shakespeare tells us how people are thinking, that in the moment when something is new and something is working better, then she makes hungry, whether she most satisfies. We want more. Antony and Cleopatra. And therefore, is there the possibility to be even faster? Yes, there is another feature. These are refreshable PDBs. Refreshable PDBs are PDBs that are created again through a copy. So if this is our data warehouse, we will have 3 hours to create the copy, but we can say, please refresh it. We can say refresh it every 60 minutes or every 10 minutes or when we prefer. And we have a perfect copy that will apply all of the changes of the first PDB. And after some time, when people will demand for a test environment, you just have to activate it in a few seconds and set all the PDBs, database PDB2, refresh mode known. And at this moment, you can activate the test environment and it takes a couple of seconds. And as you are proactive, you will probably start a new refreshable PDB, waiting for the developer to destroy the test data and come again and say, hey, we need another copy, and you will have it prepared. That's an Avasum feature. So takeaways: downtimes can be reduced during upgrade and patching. Provisioning of new test environment can be fastened. And the Swiss Mobilia blog shows again success stories. Look here, what does it take to migrate 735 database to 19C in a weekend? So they really achieved to migrate 735 database to 19C in a weekend. That's great. That's absolutely great. Reducing operation times allows you then to focus on more important things. And here I just want to point it out another time, 735 PDBs in a weekend. Great. So if you have a little bit of more time, you can maximize the agility. So wisely and slow, they stumble that run fast. That means if you are starting to become agile and you're not prepared for it, you will stumble. On the other side, just prepare and take the time you have and start running. Again, the infinity loop. And here we will see that it deals with so many tasks: automation, continuous delivery and testing, DevOps. There are so many new things that are coming and people will have to be prepared. And this was again from the presentation from Alan Fura from 2016. He knew that there were new challenges. People were demanding for a DB as a service, an interface to create automatically databases during creation of new test environment and during automatic testing. Maybe some database would live only some seconds. And they set up, having the time to provide it now, they set up with a multi-tenant option, the solution with a self-built REST API, where this REST API creates a PDB when a new application is deployed and gives back the service of the PDB. Then the pipeline runs on, and after some times, we will get After 8 minutes, the PDB will be there and the application will be deployed with the PDB, so including the database. They did their own REST data service. If this morning you attended Manuela Mustatea's presentation about ORDS and HTTPS and Liquibase and Jenkins, you will see that this is also possible with free tools in the Oracle database. For example, the Oracle REST data service. With a REST data service, you just have to issue a short HTTPS command and you can create a pluggable database, or you can do some schema changes. And Liquibase. Liquibase is a tool, an open source tool you can use for tracking schema changes or for versioning your database script. That's an important thing. So if you deploy the application 1.1, you know that you need the database version 2.7. And with Liquibase, you can do it. And hey, the big news is that Liquibase is integrating with the SQL CL. SQL CL is a command line of the SQL developer. About this topic, Jeff Smith, the product manager, will talk this evening in the keynote. So if you are interested in see how it works and what it means, just dial in for the keynote. And so I borrowed from Manuela's slide, and this can be a pipeline. When you have your version control through Jenkins, you have a pipeline. You can do the PDB clone via REST APIs, apply the changes through Liquibase on your schema tasks, and deploy in the meantime also your application. And you can then drop at the end the PDB if you want to drop it, if it is a test environment. So the DBA as a service interface was a great success. They created about 1,200 PDBs and deleted more than 500 PDBs in 1.5 years. And that's also very interesting. Also, the deletion is automatized. So normally you have a problem in deleting PDBs because you do not know who is responsible for it. Now the application, when you dismiss the application, it's done by itself. Okay. And the way of working of the DBA changed. They were not more responsible for deploying and creating new databases, doing some monkey scripts, but to provide new functionalities for the DBA as a service and integrate more in the company. So there's a tide in the affairs of men, which taken as the flood leads on to fortune. Shakespeare says us that if you see that there are some changes, you should take the flood and go for it and have new possibilities. And this time here is very important because when this is just one of the different frameworks that companies use for getting agile. And here, for example, you have the DBAs are so-called shared service in the Scale and Agile framework. And because these resources are specialized, often single sources and typically quite busy, they recognize that DBAs are busy. And Art and Solution Train, the feature team, must plan to engage them. And this means if you have to engage somebody, maybe you will try to do it without taking a resource that's very busy and that's difficult to have, and do it yourself. And once again here, Shakespeare says us that maybe you have something important to say, but we are fearing of saying it. No, we should participate to this discussion. The job of a DBA will change. Less operation and more consulting and more taking part, because DBAs are the ones who know best the environment. And once again, we DBAs, we are the people who know that all that glitters is not gold. So not every solution that comes from the development maybe is a solution that really fits in your company. Just one example, the last example is about polyglot persistence and data models. In this discussion here, DBAs should participate because yes, you can have a hybrid environment with a MongoDB that have to store JSON in the database and Elasticsearch with full text and maybe Neo4j for graph databases and so on. But there will be somebody who will have to maintain and patch and monitor and lifecycle this database. And you will have multiple data sets to back up, administer in many different ways, and different security implementation, different data classification for each tool, because maybe in some tools you will not have at all transactions. And you will have to deal with ACID and base. There's a big difference. On the other side, maybe you can have a look and say, okay, many of these features are also possible in the Oracle database. Let's work together and see if you can use the technology we just have in our house. JSON, there are quite a lot of it. JSON is very interesting in the Oracle database because it has the possibility to use both of the different technologies. The JSON technology, and you can map it immediately to a relational database. And you can play with both of them. So you have the strength of both the different types of data. Okay, so this is the end of my session. The summary is one again, a quote from William Shakespeare, and he says, as money go before, always do lie open. That means that in Shakespeare's work, money complicates things. He was not very interested in money, but he knew that money can make life much easier, greasing wheels, buying respect, and providing opportunity. And I think that this is what we should do. And now I'm ready for the question and answer part.
So in the question answer part, we have Maurice Zug, who said which actor was number 8.
Okay, so only one answer I see. Oh, that was not easy, maybe.
I have 2.
You have 2. Okay, we can. So let's see if there are some questions.
I had several ones, but I was not.
Well, we can go through it. There are some interesting anecdotes I have seen during preparing the presentation, exactly.
But it was quite interesting to see how Shakespeare fits in the Oracle world. Never thought about it.
Yes, sorry, I wanted to start my camera again. Okay, so I think we can stop the recording now. And for the people who want to stay, we can go very fast through the slide and see who were the different actors that. Okay. Whoops, what happened here? Sorry for that.